Hey, this is Horner, and this is question 2 for section 5.1 for momentum, and this is the second of 2 of the problems for the test coming up. So here we go. We have a 2 kilogram frictionless cart. So frictionless is really important because we don't have to worry about friction then. It is moving at 3 meters per second to the right, and it collides with a second cart initially at rest. So this one is moving not at all, so it's 0 meters per second. The next thing that we're going to do here is when it combines, they went through and they found what the force is for the 2 carts. And so you'll see that in half a second, the force gets really big and then gets to a peak, and then after that, the force goes back down. When the second cart is hit, it says the second cart acquires a speed of 1.6 meters per second to the right. They want us to go through first and calculate the magnitude and direction of the velocity of the 2 kilogram cart after the collision. So we don't know what the final speed is of this one, but we do know that the final speed of this one is equal to 1.6 meters per second. Alrighty, so let's do this. Let's find out what is the area under the curve. So why do we want to find the area under the curve? Well, one thing that you have to realize, and one thing that we're going to do here, is we know that impulse is force times the change in time. And that is equal to mass times change in velocity. So remember, impulse is equal to the change in momentum. And so our equation for impulse is either F delta T or it is M delta V, because these both are impulse. And so what we can do is set those equal to each other, and that makes it a lot easier to do. The other thing that we need to realize is force times time. So if I do the slope of each one of those lines, that would be force divided by time. But we're not going to do that. We want the area. So we want to know what is the area under the curve. So to find the area, we're going to multiply the two, the force times the time. But watch out, because this is a triangle. So you'll notice that this right here is a triangle, and I have an identical triangle just flipped the other way. And so let's go ahead and find out what is the area of the triangle. So we know that I have force times delta T for this triangle and force times delta T for this triangle, and we just want to add those two together. Well, because they're the same, I can just say that the impulse is equal to 2 times the force times the change in time. And so why do I want to do that? Because I'm going to find each one of these for the 2 triangles. So this would be 2 times 1/2 of the base. So the base would be our time. 1/2 the base times the height, which is the force. So that's kind of how you want to think about this. So now we're going to go ahead and put our numbers in. So this would be 2 times 1/2 of the time. And the time here, be really careful. Notice that this is 0.5 milliseconds, and milli means 1,000th, or times 10 negative 3. So this is 0.5 times 10 to the negative 3rd, and then our force here is in kilonewtons, which is 1,000 times. So if we go over and go up, you'll notice that the biggest part here is 10, so that would be 10 times 10 to the 3rd. Don't square anything. I know that we've done a lot of change in kinetic energy and those type of things, but don't square anything here. All right, so now that we have all of this stuff, we need to do our math, and we find out that we do get 5 newtons times a second. So why is the unit a newton times a second? Because remember, it is force, which is a newton, times a second, times time, which is a second. So how much credit do you get for this? You actually get 2 points for doing this. You get 1 for showing that this is impulse is equal to the change in momentum, and then you get 1 point for solving for that 5 newtons times a second. Next thing they want us to do is figure out what is the mass of the cart. So we want to know what is the mass of the cart. Well, oh, you know what? The one thing that we haven't done on this one is calculate the magnitude and direction of the velocity of the 2 kilogram cart. So we're still not done with this part. So let's go ahead and finish it up. We know that the momentum of the second cart afterwards, okay, is equal to, so here we're going to have the momentum, okay, minus that change in momentum. So we're really just looking at the change in momentum overall here. So I'm going to get rid of this guy. And that is equal to, so this is 2 kilograms times 3 meters per second. So where did I get that? That 2 times 3 is our original momentum, okay? And so we are going to subtract from that the change in momentum, which is 5 newtons per second, and you end up with 6 minus 5, which is 1 newton times a second. And that is our momentum after. So now, and this is the momentum of the 2 kilogram cart, so now what we want to do is say, well, momentum is equal to the mass of the 2 kilogram cart times its velocity. I know that the change in momentum is 1 newton times a second, and that's equal to the mass of that cart, which is 2, and then that's times the velocity. So our velocity here is equal to 0.5, because 1 divided by 2 is a half, meters per second, and it's positive, so it is to the right. Okay, so now we can go back and add the other points. Finding this momentum of the 2 kilogram car after is a point, and then finding out what the actual speed is with the correct direction is another point. Now we are done with part A, which is 4 points. Let's go ahead and take a look at part B. For part B, they want us to calculate the mass of that second cart. So here we go. We know that the momentum of the 2 kilogram cart before is equal to the momentum of the 2 kilogram cart after plus the momentum of the entire thing afterwards. So we're just going to put momentum of that mass afterwards. So we know that this is 6. It's equal to 1 plus, and then we have the mass times the velocity, which we said was 1.6, and this is for our second car, so you see that right here. Okay, so the momentum of the 2 kilogram cart before is equal to the momentum of the 2 kilogram cart after plus the momentum of that unknown mass cart after, but we do know its speed is equal to 1.6. So where did we come up with m times 1.6? Or remember, this right here, momentum is actually just mass times velocity. So this would be the mass of car 2 times its velocity is equal to the mass of the 2 kilogram cart original velocity. So this is final velocity and final velocity. All right, 6 minus 1 is 5. That's equal to m times 1.6. And so our mass here is equal to 3.1 kilograms. So now I've calculated the mass of that second cart. How many points do we get for doing all this? You get 1 point for this original equation. You get 1 point for solving or plugging everything in, essentially, and 1 point for the right answer with the right units. After the collision, the second cart eventually experiences a stop, experiences a ramp, and it goes up that ramp without any friction at all. So here we see what the velocity is of that second cart as a function of time. So let me set this up for you. This is what it actually would look like. So I have cart 1 is right here, and then we have our second cart. The two carts combine, and then this cart number 2 then starts to travel up the incline. So we're going to put cart 2, this is cart 2, and cart 1. Or the 2 kilogram cart, and then the 3.1 kilogram cart. So this is the 2 kilogram cart, and the 3.1 kilogram cart, 3.1 kilograms. They want us to find the acceleration at t is equal to 3 seconds. So this is really easy because we have speed, we have time, and we know the slope of the speed versus time graph is acceleration. How do we know that? Acceleration is equal to the change in velocity over the change in time. And so if I find the slope, which is the change in y over the change in x, so this is really slope is equal to the change in the y value divided by the change in the x value. And well, you can go through and do that really super easy. And so let's go ahead and do that. So we know that our change in y, our final y, be careful here, is 0.5. So the thing furthest to the right is the final, because time always moves from 0 over to 5 here. So that'd be 0.5 minus, and notice that this is 1.6. And we're going to divide that by the change in position. And our change in time, not position, but our change in time. And so this is 3.5 seconds. That's our biggest time right here. And then we subtract 2 seconds minus 2. And we end up with an answer of negative 0.73 meters per second squared. So how do we get points? We get 1 point for doing all this work, and we get 1 point for the right answer with the right unit, and it needs to have a negative sign. The last thing that they want us to do is calculate the distance traveled by the second cart during the 5-second interval after the collision. Okay, so they want us to find the distance that is traveled. So to find the distance it's traveled, we're just going to go through and remember that velocity is equal to change in position over change in time. So if I want change in position, all I have to do is take the velocity times the time, which means I just need to find the area of each one of these three things that I have here. So we're going to do one in green. This one in green is super easy because I'm just going to take my 1.6 times, and then this is 2. Here I have a trapezoid, and so the equation for a trapezoid is 1/2 of base 1 plus base 2 and times the height. And then this last one is just going to be 0.5 times. And then here I've got, that's 0.5, and then this is going from, now remember we don't worry about this part. So here we've got 0.5 times, and this is 1.5, because going from 3.5 to 5 is 1.5. So now we just need to go through and plug everything in to kind of figure out what we get. So 1.6 times 2 is going to give us 3.2. Here we have 1/2 of base 1. Okay, so this is base 1. We have to kind of turn this thing more like this so that we can see where our bases are. So this is base 1. This would be base 2. So there's our two bases. This base on the bottom, we notice, is 1.6. The base on the top, which is base 2, is 0.5. And then the height of this entire thing would be from here to here. And so that would be 1.5. So for this guy right here, we're going to do 1/2 of base 1, 1.6, plus 0.5. And then we're going to take that times the height, which is 1.5. And we'll get a number for it. And then we're going to do the last one, which is 1.5 times 0.5, and that's equal to 0.75. So now we can go through and do all of our math. We know that this is 3.2. This, when you go through and do it, is essentially going to be 1.6. And then this little part here in the end is 0.75. So we're going to add all those things together. So we're going to take 3.2 plus 1.6 plus point, and let's go ahead and, well, we can round it to 0.8. Let's do 0.75, and then let's see what we get. 6 and 5 is 11, so this is going to be, oops, sorry. So the 5 goes on the very end here. 7, 9, so this is going to be 9 and 6 is 15. 3, 4, 5, and so I get 5.55 meters, and that is the distance traveled by the cart in that second part. And then for the very last thing, it says state whether the ramp goes up or down and calculate the maximum elevation reached by the second cart on the ramp during that 5-second interval. Okay, so to do this, we know that it's got to go up, and we know it goes up because there is a negative acceleration. So we just need to say up, and that up is going to be 1 point. The next thing we're going to do is we know that there's got to be conservation of energy. So when I start at the bottom of the ramp and I go up to the top, all the energy here is kinetic, and all the energy here is potential energy due to gravity. So we know that we have our original velocity here is equal to 1.6. We know that our final velocity is 0.5. So our final velocity here is equal to 0.5. And so let's go ahead and say that our change in kinetic energy should be equal to the change in the potential energy due to gravity. Our kinetic energy is 1/2 of the mass times the final velocity squared minus the original velocity squared, and that's equal to the mass times the gravity times that change in height. And they want us to figure out the maximum elevation, so we're looking for the change in height. The masses we can cross off, and so now we are left with the following equation. We're left with 1/2 of the VF squared minus VO squared, and then we're going to divide that by G. And that should be equal to delta Y. So let's find out what delta Y is. It's 0.5 times, and then we've got 1.6 squared minus 0.5 squared, and we're going to divide that by 10. So when you do your math, you should end up with 0.12 meters, and that is your final answer. So we said up, we get conservation of energy here, so doing everything that you see in this area is worth a point, and then your final answer with the correct unit is a point. And that is a long problem.